Hi, hello everyone. Welcome to SK Academy of Mathematics. Today let us learn how to simplify the function. The given function u equal to f of y minus x by xy comma z minus x by zx. With respect to what condition it represent the function? It represent the composite function. And we need to prove LHS equal to 0. How to represent and how to differentiate? Now let us see. First, let us consider the given, that is u equal to f of y minus x by xy comma z minus x by zx. This function we call it as composite function. How we are going to represent it as composite function? Function inside the another function we call it as composite function. Now we need to represent this and simplify with respect to chain rule. That is, first I need to let us consider p, which is equal to y minus x by xy, q, which is equal to z minus x by zx. Then just split it. This can be represented as u equal to f of p comma q. Since I need to differentiate, now what is my aim? My aim is to differentiate u with respect to p comma q, but pq should be differentiated with respect to x, y, z, and the resultant should be represented with respect to dou u by dou x, dou u by dou y, and dou u by dou z. How to simplify? It is very easy. First consider p. Just split the denominator and the numerator, that is y by xy minus x by xy. X get cancelled, y get cancelled. P, which is equal to 1 by x minus 1 by y. This is our P. Similarly, split the Q, which is equal to z by zx minus x by zx. X get cancelled, z get cancelled. Q, which is equal to 1 by x minus 1 by z. First, let us find dou u by dou x. To find dou u by dou x, first p should be first dou u to dou p. Dou u to dou p. P should be differentiated first with respect to x. That means p by x. The same way chain rule. Next, u to p. Sorry, u to q. Dou u by dou q. Q2 with respect to x. Q with respect to x. Done. Now dou u by dou x, which is equal to dou u by dou p, remains constant. Now I need to differentiate p with respect to x. So what I am going to do? See, first let us see the first step. We have x. What is differentiation of 1 by x in this step? 1 by x is minus 1 by x square. Minus, since we don't have any term in the 1 minus 5, this becomes 0. Minus 0 plus dou u by dou q. Now I need to differentiate q with respect to x. See, I have 1 by x, differentiation of 1 by x, we have minus 1 by x square. Minus, I don't have any x term, so it becomes 0. Then dou u by dou x, which is equal to dou u by dou p into minus 1 by x square, minus into plus minus dou u by dou q into 1 by x square. Yes, then dou u by dou x, which is equal to minus dou u by dou p into 1 by x square minus dou u by dou q into 1 by x square. Done. Now what they have given? They have told to multiply x square. Multiply x square on both sides. What we are going to get? X square dou u by dou x, which is equal to minus dou u by dou u by dou p into x square by x square minus dou u by dou q into x square by x square. X square get cancel, x square get cancel. You get dou x square into dou u by dou x, which is equal to minus dou u by dou p minus dou u by dou q. We have got x square dou u by dou x. Now similarly I need to find y square dou u by dou y. To find first let us find dou u by dou y. How? Say first u to p, p to y. Dou u by dou p into dou p by dou y plus dou u by dou q into q to y, dou q by dou y, that is dou u by dou y, which is equal to dou u by dou p into dou p by dou y. Differentiate p with respect to y. First term we don't have any y variable, so this first term becomes 0 minus differentiation of 1 by y square with respect to y, it becomes minus of minus 1 by y square plus dou u by dou q remains constant into q with respect to y. In the first term we don't have y, becomes again it becomes 0 minus in the second term also we don't have y, so it becomes 0. Next dou u by dou y, which is equal to minus into minus plus dou u by dou p into 1 by y square. Now since I need to multiply y square, multiply y square on both sides. What we are going to get? Y square into dou u by dou y, which is equal to dou u by dou p into y square by y square. Y square get cancelled. Y square dou u by dou y, which is equal to dou u plus dou u by dou p. This is our the second term, that is y square dou u by dou y. Similarly, let us solve dou u by dou z. That is, let me solve here. Dou u by dou z. Dou u by dou z, that is u with respect to p, dou u by dou p. Now p with respect to z plus dou u by dou q by dou z. This we call it as the chain rule. Now dou u by dou z, which is equal to dou u by dou p is constant into I need to differentiate p with respect to z. Since in this term we don't have z, this also becomes 0. In this term also we don't have z, this also becomes 0. That is 0 minus 0 plus dou u by dou q into, now in the first term we don't have z, it becomes 0 minus we have 1 by z, differentiation of 1 by z minus 1 by z square, that is dou u by dou z, anything multiplied by 0, 0 plus dou u by dou q into minus plus 1 by z square. Now I need to multiply z square on both sides. What I am going to get? Z square dou u by dou z, which is equal to dou u by dou q into z square by z square. Z square get cancelled. Z square dou u by dou z, which is equal to dou u by dou q. Consider this as equation 1, consider this as equation 2, and consider this as equation number 3. Now, after this, add equation 1, 2 and 3. That is x square dou u by dou x plus y square dou u by dou y plus z square dou u by dou z, which is equal to minus dou u by dou p minus dou u by dou q plus dou u by dou p plus dou u by dou q. Minus plus minus plus get cancel, you get x square dou u by dou x plus y square dou u by dou y plus z square dou u by dou z, which is equal to 0. Hence proved. Hence proved. I hope you have understood how to find the composite function step by step. With respect to chain rule, first we have considered PQ, differentiated with respect to x, differentiated with respect to y, differentiated with respect to z. Adding all these three equations, if you add, LHS will be equal to 0. That's it. I hope you have understood this problem. For more videos, please do like, share and subscribe. See you in the next video. Thank you.